In this part, I will focus on the methodology of econometrics, or steps that you should follow when you deal with econometrics, when you want to apply it to some economic theory. On this slide, you can see that there are 8 steps that I strongly recommend you to follow. And let's go through each of these steps one by one. So in the first step, obviously, we need to do some statement of theory or hypothesis that we would like to test. And as an example, I've chosen the marginal propensity to consume theory that I believe that all of you are familiar with. We discussed it during the class of economic analysis, and you should have discussed it during the class of macroeconomics. So the first time this theory was stated by Keynes, and it sounded as follows: the fundamental psychological law is that men and women are disposed, as a rule and an average, to increase their consumption as their income increases, but not as much as the increase in their income. In other words, the rate of change of consumption for $1 change in income is greater than 0 but less than 1. We know it as the marginal propensity to consume, so when income increases by $1, consumption increases but less than $1. So let's say that this is the theory that we would like to test. We haven't done this before, we just believed Keynes that this is true, but now luckily we have the tools to test whether this theory is true or not. In the next step, we need to specify the mathematical model. And we've done this before, and actually this is the model that we are already familiar with. So on the left side, y is consumption. On the right side, beta 1 and beta 2, those are the parameters of the model. Beta 1 is an intercept, beta 2 is a slope coefficient, or the very famous marginal propensity to consume, and x, which is income. This is the model that we saw before. Maybe we had different notations. Instead of y, we had c. Instead of x, we had y. But the model is exactly the same as the one that we dealt with. On the right side, you can see the graph of this model. So on the horizontal axis, as always, we put the variable that is on the right side of the equation. So the independent variable, which is in this case is income. And on the vertical axis, we put the dependent variable. In this case, this is consumption. So beta 1, this is the intercept. When x is 0, y is equal to beta 1. So this is the first point of the straight line. And then we built this line where beta 2 is the slope of the where beta 2 is the slope of it. And again, I think we've built similar graphs before. So this is just a graph of a straight line of this equation here on the left side. So for now, these 2 steps are very much familiar to us. We've dealt with them before. And let's move to the next one. So after we have specified the mathematical model, now we need to specify the econometric model. And if you compare this equation to the equation from the previous slide, you will see that it is very, very much similar, with the exception of the presence of the U term, which is known as the disturbance or error term. Again, this is something that we discussed with you during the class of statistics. That was actually during the last classes of it, when we entered the world of regression analysis and correlation analysis. We did simple things. But anyway, we still had time to discuss the error term. We also calculated it, and I hope that you remember that I told you that in the end, when we sum them, they should be equal to 0. Anyway, I will discuss this term in more details later during the upcoming lectures, but for those who are interested, I will give a quick interpretation of it. So if we look at this graph, you will see that the line, this is the graph of this mathematical model with without u, obviously. So this is, we can say, the predicted values of y based on the value of x and this equation. So when we substitute the value of x using the estimated values of beta 1 and beta 2, we get the predicted values of y, and when we put them on a graph, we get a straight line. The dots, those are the true value of y. So the one that are taken, let's say, from the database, the real values of y, and the difference between the real value of y and its predicted value by the model is the error term. If it's still not clear, don't worry, I will discuss it in more details later during the upcoming classes. So after we have specified the econometric model, we can move to the next step, which is obtaining data. So in our case, in our example, for our example, we need two variables. We need two data sets, the one for y, which is consumption, and for x, income. We can get this data easily from one of the mentioned data sources. So here on this slide, I've mentioned the most popular ones, the publicly available sources. So in the future, when you will need data, you can easily go to one of these databases and get the data for your projects, for your dissertations. So OECD Statistics has the data for OECD countries. The World Bank has the data for all the countries in the world. International Monetary Fund data also has data for all the countries. Eurostat, this is the database of the European Union. FRED database, this is the American database, so I think it will have data only on the American economy, and the same with the other data source. Anyway, there are other data sources, reliable data sources, by the way. You should use only reliable data sources. So if you're not sure which one is reliable, you can always ask me, or to be on a safe side, you can just use one of those mentioned here. So after we've collected data, now we can finally estimate the econometric model. And we've done this before with you. That was during the class of statistics. We used some formulas and we estimated the model. Luckily for you, this semester we will do this with the help of a computer, or to be more specific, we will use some special econometric software. And again, here on this slide, I've mentioned some of them. EViews, this is the one that we will be using during this semester, so I already recommend you to download it on your computers. There is a student light version, which is for free, so you don't need to pay for it, which is good. We'll also have it on our computers at the university, so I hope we will be able to use it as well. There is another free software, Gretel, which is actually preferred by some people more than EViews. The other two, Stata and R, those are more complicated software. They're more advanced, I would say. Stata, unfortunately, is not free, but R is free. But to use R, you need to understand a bit of coding. But it's not that difficult, to be honest. Anyway, let's go back to the model that we have above. So let's assume that we've used one of these softwares to estimate this model, and those are the results that we get. So beta 1, the intercept, is equal to approximately 300. So when x is 0, income is on average equal to 300. And the beta 2, the marginal propensity to consume coefficient, is equal to 0.72. So we can say that $1 increase in x, in income, leads to 0.72 cents increase in y. And if you remember, the coefficient should be between 0 and 1, and in our case, this is true, it lies between 0 and 1, like the theory predicted, like Keynes stated many years ago. So it might happen that his theoretical prediction is very much correct. But unfortunately, for now, we can, even though we have this estimation result, we still cannot say whether his prediction is correct or not. So to be able to say that his prediction is really correct, we need to do something called hypothesis testing. And this is the next step in methodology of econometrics. So before accepting this finding as confirmation of Keynesian consumption theory, we must inquire whether this estimate is sufficiently below unity. In other words, is 0.72 statistically less than 1? So what we need to do, we must undertake hypothesis testing. This is a long procedure and it involves various steps, various econometric tools. Therefore, I cannot discuss it right now. but I will show you how to do that during the course of this semester. So for now, what you just need to know that after you've estimated the econometric model, you cannot say that the results are true. You need to prove that they are true using various hypothesis testing tools, which we will learn later during this course. Let's assume that hypothesis testing showed us that the results are okay, that they can be trusted. Then in the next step, we can use this model for forecasting and prediction. So let's assume income. So we predict that income in 2021 will be $11,319 billion. So given this value, we can predict the value of consumption at the end of 2021. So we use the estimated model. So instead of X, we substitute its value that is given above. And in such a way, we obtain the predicted value of consumption for 2021. I think it's not that difficult and it's quite intuitive. Unless you have some problem with understanding this equation, if you have a problem with understanding this equation, please let me know. And finally, the last step of the methodology of econometrics would be, not necessarily, but you can use this model for controller policy purposes. And actually, this step shows you that econometrics is very much used by economists, by politicians. It is used by policymakers to come up with policy measures that are necessary, let's say, for either keeping the economy in the state it is now, or for improving the state of economy, or for stabilizing the economy. So for various reasons, but in simple words, it is used for policy purposes. So suppose the government believes that consumption of about $8,750 billion will keep the unemployment rate at its current level. So in this case, the policy purpose is to keep the unemployment rate at its current level. And they want to know the level of income that will guarantee the target amount of consumption expenditure. Again, we can use the equation, but this time the variable that we know, the value that we have, is the value of consumption Y. So we put it on the left side, and given this equation, we can estimate the value of X, and we predict that income should be around 12,539. So this income will guarantee the current level of unemployment rate.